Hi, I'm Chris Hamilton from Rega Ventilation, and I'm here to talk to you today about reducing energy consumption and heating costs with heat recovery ventilation, or mechanical ventilation with heat recovery. So new build homes these days are built a lot more, they're trying to work to a lot higher airtight standards. They're trying to make them as well insulated as possible to try and bring down heating costs and to reduce overall power consumption of the buildings and things like that. But what that comes with is a necessity to ventilate the property. So older properties, they would have had enough natural leakage that there would be quite a lot of air infiltration in and out of the house. But once you remove that and increase the air tightness of the properties, you need to bring fresh air into the building somehow and get rid of your stale, moist air and condensation, things like that. So what that is normally done by, there's a few different systems, but the main one that it's normally done with is trickle vents mounted into all of the windows, which will be there to allow infiltration of fresh air into the house. And each of the wet areas in the bathroom would have extract fans. So you would have you've got a system, so your extract fans are pulling all the wet air out of the bathrooms, kitchen, utility areas, and your trickle vents are supplying your replacement air. Now, the problem with that is, obviously, because they're just natural sources of ventilation, the extract fans are on when people are in the bathrooms, but the trickle vents just allow fresh air into the house. The problem with that is if it's a cold day outside, you're going to be letting cold air into the house, which your heating system will then have to heat back up again. And because it depends on external conditions, how much air is going in and out of the trickle vents as well. If it's particularly windy outside, you might get a lot of air replacements. If it's not very windy at all, you might not get enough. So it's not very well controlled either. An alternative to that is mechanical ventilation with heat recovery. So what you do is you have a system that runs ducts all around the house. You've got a centrally located ventilation unit which has two fans in it. One side of the system is pulling fresh air in from outside, while the other is extracting the stale air from the wet rooms, bathrooms, kitchen areas in the house. The stale air is brought back to the main unit, and the extracted stale air, the heat is taken out of it and put into the fresh air that's coming in from outside. So that fresh air is then supplied to all the living areas in the house, so your bedrooms and everything, and the stale air is exhausted to outside. So you essentially completely replace the air within the house, but you haven't lost any of you haven't lost all of the heat when doing so. And the systems are normally around about 90% efficient. So what that means is if it's 20 degrees in the house and 10 degrees outside, you can be bringing fresh air into the house at about 18-19 degrees. So it means, as opposed to the alternatives, your heating system doesn't have to work anywhere near as hard to get the air back up to temperature. The systems are all equipped with low power consumption fans to keep the energy costs and things as low as possible. And there's other benefits that come along with the systems, as well as the heat recovery aspect, such as improving air quality within the house. So because all the air you're bringing into the house is filtered, it's standard it's always dust filtered, but you do also have the options of adding things like pollen filters to the system, which can reduce allergens, pollutants, anything for asthma sufferers, fine dust particles, diesel particles, things like that. They can all be removed from the system, which obviously means you can create a much healthier atmosphere within the house. There's also benefits in terms of noise levels of the systems. Trickle vents, because they are just open vents to outside, if the house is near a road or anything like that, you can often get traffic passing by and that noise from that. But the systems are also can be fitted with acoustic ductwork to stop any fan noise travelling down the duct system or noise going between each room, so you can really make sure that there's no noise. And The extract fans that are typically used in bathrooms, because they're working on a purge ventilation style, where they will only run for a short period of time, they will move air a lot quicker than an MVHR system, which runs constantly at a slower speed. So what you essentially end up with is a quieter vent within the bathrooms, because there's less air noise. So you may be wondering about how an MVHR or a heat recovery fit system is going to fit into your project. So as I mentioned earlier, the systems are comprised of a main unit and a duct system. So in terms of main units, normally you'd have either a loft mounted or a wall mounted central unit. There's not really any benefits to which one of these you use. It really comes down to project, what spaces you've got available and what would be most suitable for you. Normally, if there's a loft space available, people will opt for having a loft mounted unit. It's got a few benefits in terms of, if you've got its unit in the loft, you're often got easy access to a lot of the rooms upstairs for the duct system, so you don't need to worry too much about dropping down. You can get most of your stuff done in the loft space. You're also closer to, you'll always be nearby the roof if you need to have your external inlet and exhaust out through the roof, or you can go through a gable wall or whatever. There's a lot more options if you're in the loft space. If you don't have a loft space available, there's absolutely no problem with having a wall mounted unit. They can be designed to go into garages, utility rooms, plant areas, and there's as long as you've got routes to get from there to the rest of the house, then that's as good a place to put it as any. They do need to be accessible for maintenance, so that's one thing to bear in mind, is that you'll need to access the units roughly once a year or so to clean the filters, make sure everything's working correctly, make sure there's no problems with it. But other than that, you don't really need to interfere with them, so you don't need to be able to access them regularly. After that, you've got the duct systems coming off the unit. So again, there's a couple of main types of duct systems that people use for heat recovery ventilation systems. You've got what's known as a branch system, which has a main duct coming off the unit, which will then branch off to various other rooms throughout the house as it runs through, and will reduce in size as it gets further away from the unit. You've also got what's known as a radial system, which a radial system, it moves off the main unit with one large duct, and then it will go into a manifold box, and you'll have lots of different smaller ducts that will go around the house. Now again, there's not really a particular one of these systems that's particularly better than the other. It all really does come down to what project, what space you've got available, void spaces, and what would be more suitable for the project in question. So branch systems, obviously the ducts are normally larger, so you need to make sure you've got the space to run the larger ducts around. But once you've headed through the once you've got through the, if it's in the loft space, a lot of the ducts will be within the loft, so branch system is often ideal for that. And particularly if it's a cold loft space and the ductwork up there might need to be insulated, you can keep costs down by using a branch system rather than a radial. But radial systems, obviously, as I mentioned earlier, because of the smaller ducts, if you've got smaller voids or certain problematic areas where you'll need to get through, then having the smaller duct is beneficial. The only thing is radial systems generally come out a little bit more expensive than branch systems, but it all very much depends on the specific project. In terms of so you've got a branched and a radial system, but you've also got a lot of different duct options available in terms of semi-rigid, rigid pipes, rectangular ducts, circular ducts. And again, there's no real benefits to any of the types of duct system. They can all be sized appropriately to keep the pressure levels down and things like that, to make sure the system's going to function as it should. But each duct, obviously, depending on the project and what the requirements are, there's going to be specific benefits. For example, rectangular duct, is ideal for installing in low height ceiling voids if you're using a branch system. And you know, if you want to keep the ceiling heights as high as possible, then rectangular ducts are the way to do that. You've got options of using, as I say, semi-rigid ducts are perfect for installation within open web joists. So obviously it's very difficult to get a rigid pipe into a web joist unless you're fitting it while the joists are being put down, which is not easy to do. So semi-rigid ducts are perfect for that. And rigid ducts are great for if you need to have ducts exposed or run ducts through loft areas where there's going to be people moving through and you want to prevent any risk of damage. You can use rigid duct, which is going to be a lot stronger and more durable in the areas where you need it to. After the duct system, you've got the vents. So it's the only part of the system that you'll be able to see when the system is fully installed and in operation. And you've got various different options of vents, but typically they will all have one thing in common, which was they'll be adjustable to balance up the airflows. Now that's really important for making sure that each room is balanced up and set to the level that you will need it to in order to meet building regulations requirements. So obviously the system is there to conform with building regulations part F, and it's outlined in there what the airflow requirements are. And if you don't want to have trickle vents and extract fans, then you'll need a MVHR system that fulfills the requirements of building regulations part F. And as I say, so they're all adjustable at the room. There are other ways of doing it, but they're a lot more difficult. So normally, adjustable vents within the room is the best way to do it. So in conclusion, there's various different duct systems available, various different units and things like that, but it all comes down to what's going to work for the project and what's going to be required. So it's all part of the design stage of the system to work out what the most suitable duct systems are. So to summarise, having an MVHR system may be slightly more expensive than using trickle vents and extract fans in terms of upfront costs, but there is a saving to be made in terms of overall energy consumption, heating costs, and also carbon footprint of the property. Normally, average sort of project, we think that there's around about a 5-year payback period when you compare the system to trickle vents and extract fans, which isn't a dramatic amount of time. Anyway, I've been Chris Hamilton from Rega Ventilation. That's all I've got time for today, but I hope that was helpful for you, and thanks for listening.